Hello? Hello? Are we together? Please, let's create the atmosphere for chemistry. Let's create the atmosphere for chemistry, please. Today, where do we stop in the chemistry, please? Who can tell me where we stop in chemistry? Where do we stop in chemistry? Where do we stop in chemistry, please? I'm asking those that came. Those that came, please. Where did we stop in chemistry? The topic is electrolysis. Where do you stop in electrolysis? No. Don't worry. I mean electrolysis. Electrolysis. Don't worry. Just calm down and look for electrolysis. Things are not done that way. Things are not done that way. Fast. Things are not done that way. Now, wait. Hello. I think it's better I use. Hello, listen carefully. Am I communicating? I'm listen. People should listen. Let me use this opportunity to tell you something you don't know. You know you are still coming up. Let me tell you. I plan to. This you stand up. Stand up, yes. Stand up. Fast. And you, hello. Stand up. Yeah, stand up. This thing you said now made me to want to address something now. These two human beings. Immediately I entered this class one day, I think last week or so. They told me, sir, change topic. Just like that, change topic. I was still trying to digest that one. Either of them says, "I do biology." I was like, I was very, very annoyed. Do you know why I was annoyed? Because even in their ignorance, I was trying to make them see why they were saying, why they were wrong in what they were saying. They didn't even see any reason. They were even arguing. Especially this human being opening his particular up and down. You know that I left. Hello. I left. Whenever I am not happy in a system, I did what my next target is to, because if I stay, I may do what I may not like. So I just left. I left that scenario. So, and when I left never to come back. If not that the owner of this place is a humble man, and the man that wants you are good, I will not have come back. This big head. Now, let me explain. My initial plan was, if I come here, I will set question for them on emotion. If they solve it and fail it, I will take them away from the class. They will never attend my class again. That was my initial plan. Then if they pass the question, they will not be trial. But I came here and forgot about it. I didn't even remember it again. But please listen carefully. If you tell a lecturer JAM has a syllabus, WAEC has a what? A syllabus. And those education, you prepare for a lecture. You prepare a lecture. It's not about you being intelligent. I can come here, without even, I can be passing and enter here and start wrapping chemistry up and down. From organic, I'll enter different topics. And you'll be coming for me that this one is too much. Then after I will go. But the question is this: have you learned what JAMB wanted to learn? Have you learned what WEC wanted to learn? That's why they have what? Syllabus. That's why I should prepare my lecture before coming. I look at that syllabus. There are some things they want you to learn. Cell. If you want to teach somebody cell and its structure in biology is a topic. But if you want to teach somebody that is in SS1 and someone that is preparing JAM and someone that is preparing WEC, if you go through their syllabus, they are not exactly the same thing. There are some points they want you to know for JAM. There's some point they want you to know for what? WEC. Am I communicating?
Yes, sir.
Addition when you were in primary 1 or even primary 1, do you know what is minus 1 minus 2 minus plus 2? Primary 1. Primary 1 is not 2. It's not 2. But as you're coming up, you know, says here which one is minus 1 plus 1 again. So every level has its own what? Curriculum or what timetable. That's why you have your scheme of work. Am I complicated? So if listen carefully. You're making noise now. Now if I prepare based on your syllabus, based on ingredients in your syllabus, what you are meant to cover, I come here to teach you based on your syllabus or on your syllabus, and I come here to teach you. Tell me go to biology. You are shooting yourself in your leg. Because I will go and teach you biology. It's easy. Now I'll start teaching biology. Two of us. I'll teach you biology. Then I'll go.
Then the right biology for
yes.
So
no, that is not specialization.
Have you done biology?
Wait, if you did biology, the person you talk to is your trainer. Then he is going to say, sir, if you are coming so day, you teach them what? Biology. Not when I come to teach them, you say teach biology. I'm telling you that if I do it, you are shooting yourself in your leg. Because you know, I may not be able to give you what you need. Yes. Now, as I'm here now, hello, as I'm here now, I can drop this and start teaching you biology now. But at the end, am I helping you? I'm not helping you. If you want to know what you are doing here is true or not, go back now. Look for WEC syllabus. Look for JAM syllabus. Compare. Go to electrolysis. Go to motion. Compare the topics what I've taken with you now here in this class. Compare it with JAM syllabus. Then come tomorrow. Next time we see. Tell me whether we are following the syllabus or not. Just do it on your own. You find out. So please, things are not done that way. That's why I say things are not done that way. Am I communicating? Alright, so now, where do you stop? Where do you stop? Who can tell me that exactly where? How many points did you make there?
4. Then the distribution.
Okay, good.
And you know what it is? You know the stupid thing said,
okay, so let's start from where we stopped. We stopped at the mechanism of what? Electrolysis, right? Mechanism of what? Electrolysis. Are we together? Are we together? I believe we are. where deposition, right? And I said that in the deposition, at the deposition state, the new substance is now what? Deposited at the what? Electrode, right? That's where we stopped. So there are some key components. You can write for the benefit of those that join us for the first time. Write this subtopic: key component of electrolysis. Key components.
That change the wish and wizard from the land.
Key component of what? Electrolysis. Remember when we drew the electrolytic cell? Remember when we drew the what? Electrolytic cell? Remember, we have. Help me with this, please. Remember when we drew the. You don't the drum. You don't want it. So. We drew the what am I going to do yourself? You can see now. Are we together? We drew something like this, right? Electrolytic cell, right? Electrolytic cell, and we said that this is the what? Electrolyte, right? Electrolyte, and this one is the cathode, right? Cathode, right? And this one is what? This one is the power source, right? Power what? Source. This one is that's the what setup. Now, this whole thing is the what? Electrolytic what cell. This is where the electrolysis process takes what? Place, right? Now, we said I want to use this key component now to do a kind of flashback to what we have discussed before, so that those that join us will now join us. I may not go deep again, but I just want to mention one or two things. The components here, the first one is the anode. Put it down. Anode. Are you alright? Yes, anode. These two things are the what? Anode and the cathode are the what? The electrodes. They are the what? The electrode, right? Yes. While cathode is the negative electrode, anode is the what? Positive what? Electrode. So anode is the positive electrode. Anode is the positive electrode. Positive electrode. Where oxidation takes place. Keep making noise. While lecture going on. So where is I said that anode is the what? Positive electrode. Where what? This side is causing me headache. This side they are calm here. So this is where I want to be now. They know too much here, so that's why they're making noise. No. They think they know too much, so that's why they're making noise. So this place are humble here, so let me start. The electrode is where is the positive electrode, right? Anode is positive electrode where oxidation takes place. In bracket, write loss of electrons. Where oxidation takes place, you in bracket write what? Loss of what? Electron. Because we say that oxidation is the loss of what? Electron. True or false? Yes. Then the second component is the cathode. Second component is the cathode. Cathode. Number two, cathode. Number two, cathode. Yes, right. So cathode is the negative electrode. Cathode is the negative electrode. Negative electrode where reduction takes place. Negative electrode where reduction takes place. In bracket you write gain of what? Electron, because reduction is gain of what? Electron. Gain of electron. The next one is electrolytes. It seems that now let me come again. If you start again, I'll go there. I like this side, but they're making me to like this place more by making noise. They're making noise here. Electrolytes. See it here. Electrolytes. Electrolytes is a substance in molten or solution form. Electrolyte is a substance in molten. I explain all these things in this class. Molten or solution form. Molten or solution form that conducts electricity. That conducts what? In molten or solution form that conducts what? Electricity. Are we together? That conducts what? Electricity. That conducts what? Electricity. The fourth one is electrolytic cell. Electrolytic cell. The fourth one, number 4. Electrolytic cell. This is a container. This is a container. This is a container. This is a container. This is a container that holds cold. It's a container that holds the electrolytes, and the electrodes. That holds the electrolytes and the what? Electrode. Yes. That holds. Yes. Yeah. That form that holds electrolyte and what? Electrode. Where electrolysis take place? Electrolysis takes what? Place. So we use the electrolytic cell to carry out what? Electrolysis. True or false? So these are the components. Now, are we together? Now let me just do a kind of 1 minute recap. What I'm going to say now is very important. Listen carefully. Even those that we are in the former class, listen carefully. I want to explain something. Okay, hope you can hear me. You hear me, right? Yes. Don't mind this book. Now, looking noise. Looking noise. Don't worry. You cry. Is this our first time of coming to the class? My class. Now, okay. Hello. Okay, now, please, I want to explain something. I want to explain something. Remember, I said, when we distinguish between electrolyte and non-electrolyte, strong electrolyte and weak electrolyte, we did all this comparison, right? Now there's something I want to let you know. Sodium chloride, for example, now. So sodium chloride is a solid sodium chloride have no business conducting electricity. Now, but when you now get this sodium chloride now dissolve it in water, if you add water now, it will become sodium chloride solution. This one can conduct electricity. Do you know why? Let me explain. There's what is called water and other solvents are called polar solvent. Polar solvent because they have two poles, two partially charged poles. We call them partially positive and partially negative poles. Am I communicating? Now, here we have hydrogen ion and hydrogen what? Ion in water. Am I communicating? Yes. Yes. Now, when this thing come in contact with sodium chloride, that's what we call solvation. This and this will impact partially the positive charge and negative charge in this sodium chloride. So as a solution, this one is as what? Solid. As a solution, aqueous solution. See how it exists. Sodium chloride is like this. As an aqueous what? Solution. This is how it exists. This will impact the water added that will impact this thing. So this is how it. So inside this place now, the same thing.
So the SO4
yes. Inside this thing now, inside this electrolyte, this is how they exist. When you now pass electric current through the power source inside this place, so what happen? The ions will start migrating. They will start looking for where they will go. This positive one will do what? Go to what? Cathode. This negative one will go to where? Electrode. Am I competing? But actually, in a real sense, inside this electrolyte, do you know how many? Who can tell me how many ions will be inside that electrolytes in sodium chloride solution? Who will tell me? How many ions? 4. What are they? You got it. What are they? I mean, if you use aqueous, I'm preparing your mind for a process of different substances we will still do. If sodium chloride solution is what is used as electrolyte, I agree with you. 4 ions will be here, or 4 species. I agree with you. Will be here. So tell me, what are they? Sodium ion. I agree. I agree. These are the 4 ions that will be inside this electrolyte here. And when you pass electric current, they will start migrating. Sodium and hydrogen, sodium ion and hydrogen ion will start competing for which one will go here first to discharge. That's why you have what you call electrochemical series. Yes, that will not determine their order in the series will determine which one should discharge first in preference to what the order. We'll discuss that. I just want to do a kind of trying to prepare your mind towards that. Are we together? Now, the same way, hydrogen ion and chloride ion are supposed to come here, right? But one will discharge in preference to the other based on their order in the what, their position in the what. The chemical says another factors. Even their concentration can also affect that. So let's stop it here. Then next subtopic. Write down the next subtopic. Factors influencing discharge of species at the electrode. Factors influencing the discharge of species. After the species, put a bracket. Ions and radicals. Species in bracket, put ions and what? Radicals. Okay? Ions and what? Radicals. You put the bracket. At the what? Electrode. Radicals. Factors influencing the discharge of species. That species, open a bracket, write ions and radicals, and close the brackets. Then continue at the electrodes. Right, that is a subtopic. Factors influencing the discharge of species in brackets, ions and radicals. You close it at the what? Electrode. Alright, put down. The discharge of species during electrolysis. The discharge of species during electrolysis. The discharge of species during electrolysis is influenced by several factors. During. The discharge of species during electrolysis is influenced by several factors. Species during electrolysis is influenced by several what? Factors, which can be categorized into two groups. After groups, you put colon. From right, which can be categorized into two groups. Electrode related factors. The first one is what? Electrode hyphen related factors. Electrode related factors. And the solution or electrolytes related factors. I said that there are several factors that influence discharge of species at the electrode, right? But they are categorized into two groups. The first group is what? Electrode-related what? Factors. While the second group is what? Solution or electrolyte-related what? Factors. So all the factors that influence the discharge are categorized under two groups. The one that concerns the what? Electrode, and the one that concerns the what? Electrolyte. Is that clear? Now let's go to the first one. Electrode-related factors. Let's look at the first one. Electrode what? Related what? Factors. Electrode-related factors. Electrode-related what? Factors. Alright. So under electrode-related factors, we have different factors under it. Do you understand what we are doing? Under electrode-related factors, there are factors under electrode. So what means that these factors concerns what? Has to do with what? The electrode itself. Now the first factor, number one factor there is electrode material. Electrode material. Electrode what? Material. You put, if you write electrode material, you put stroke what? Nature of what? Nature of what? Electrode. Is it clear? Electrode material, you put slash nature of what? Electrode.
That was very tall. It's like almost like like 9 feet tall for some guys is 9 feet tall. And now when you get on this,
then after that, put colon. Then continue. Yes. Yes. I want to say one or two things there under the nature of electrode or the type of electrode. And there's case it can be the type, nature, or. Is it clear? Alright, so the type or nature of a electrode material, the type or nature of the electrode material, the type or nature of the electrode material, the type or the nature of the electrode material used, the type or nature of the electrode material used can influence the discharge of species. Can influence the discharge of what? Species. Right, full stops. The discharge of what? Species. When you say that something is inert, what does it mean? When you say that something is inert, what does it mean? Hello? When you say that something is inert, I-N-E-R-T, what does it mean? No. In chemistry or whatever, in science, when you say that something is inert, what does it mean? When something is inert, what does it mean? I know that noble gas are inert. What does it mean? Not reactive. Reactive. Good. Not what? Reactive. Okay. So let's continue. For example, right. For example, EG is okay. And anyone. For example, yes. Yes. For example, inert electrode like platinum. Inert electrode like platinum or graphite. Inert electrode like platinum or graphite. Platinum, graphite. They're inert now. Or graphite. Inert electrode like platinum or graphite may not react with the electrolytes. May not what? React with the what? Electrolytes. May not what? React with the what? Electrolytes. May not what? React. I will say two of you. No. I will do that. Yes. That electrolytes. No, they're not. Remember we are talking about this. We are talking about electrode now, not electrolytes. We are talking about the electrode. So we have inert electrode like graphite or platinum. These ones they are inert. They don't react with the what? With the what? Electrolyte. Am I communicating? Just I will explain. Just put that so I will explain. Why reactive electrode? While reactive electrodes like copper, while reactive electrodes like copper or zinc, while reactive electrodes like copper or zinc may participate in the reaction. While reactive electrodes like copper or zinc may participate, while reactive electrodes like copper or zinc may participate in the reaction. May participate in the what? The reaction. Yeah, why reactive electrode? Like what? Copper or zinc. So what does this mean? No, they don't react with the electrolytes. Even though, hello, no, yes. See what I mean? I don't like this. I don't like this. Please, let's focus, please. We have roughly 20 minutes to go. Please, let us listen, please. Are we together? What's that? Yes. Is it okay like that? Are you good? Now listen. Hello? Who is that there? Huh? Hello, please, let's focus, please. I want to explain this. Just listen, please. Now, we are trying to point out that there are some electrodes that are inert, some are reactive. Now, something like graphite or platinum, you know that everything, the ions are all in this world electrolytes. Am I competing? And there is a contact between the electrode and the electrolytes. Depending on what you want to achieve, there are some electrolytic process you want to carry out. You don't need the electrode to react with content of the electrolyte. So if you use an inert one, they will just discharge there. That's all. But if you use the one that will react with it, it will affect the ions there, because complexes will form. I cannot speak out. Yes. That's reaction now. But basically, I have a headache. I don't take all those things. Water. I don't take water. Are we together? So if the electrode reacts with what is inside here, it will affect the discharge. True or false? It will affect it. So the activity of the electrode with the electrolyte influences the discharge of the ions. By the time we go over into the application of electrolysis, you start seeing things like electroplating and the purification of substances from their crude form. You now see the importance of the type of electrode. That would mean the type of electrode you use. Because you may need the one that may be reactive. You may need the one that may not be reactive, depending on what you want to achieve. That's why I say, depending on what you want to do, achieve. But if you use the wrong electrode, it will affect your work. True or false? That's why we study the factor, so we know exactly what we are doing. True or false? Now, the next point is electrode surface area. Electrode surface area. Let me see. Yeah, right. The second factor is electrode surface area. Electrode surface area. Yeah, under electrode materials, electrode surface area. Sorry, madam. Yeah, column. Are we good? Yes. Good now. All right. yes, a larger surface area, a larger surface area, a larger surface area can provide more sites. A larger surface area can provide more sites. Yes, sites. Sites, look at it on the board. SITES. A larger surface area can provide more sites for discharge. A larger surface area can provide more sites for discharge.
More sites for discharge.
More sites, yes, for discharge, comma, thereby increasing the rate of reaction. I love this, man. Thereby increasing the rate of reaction. Yes. I said that a larger surface area can provide more sites for discharge. Sites. Comma, thereby increasing the rate of what? The rate of what? Discharge. Oh, sorry, reaction is okay. Sorry, reaction, no verse. Reactions. Thereby increasing the rate of reaction. Thereby increasing the rate of reaction. So when we say reaction now, what reaction are we talking about now? Who can tell me? When we say that this large surface area can provide more larger site for the discharge, thereby increasing the rate of reaction. What type of reaction are we talking? What type of reaction are we talking about now?
So what's the question again?
Everything is under electrolysis. Fine. I said that the larger the surface area of the electrode now, not electrolyte now, decomposition takes place inside the electrolyte. So that decomposition reaction is gone. The first step is decomposition, right? Because here now this is decomposed. Two of us. That one is gone. There's another reaction that will take place. So when at that electrode, the larger the surface area of the electrode, the larger the more site for discharge, and the increase in rate of reaction. What reaction? What reaction takes place at the electrode? God bless you. Redox reaction, just redox takes place in what? Redox reaction. Re means reduction, ox oxidation takes place at the what? Electrode. But the cathode is for what? Reduction. You are playing too much. Cathode is for what? Reduction. Anode is for what? Oxidation. But the reaction we are talking about is what? Redox what? Reaction. So if you now mention the particular electrode in question, you not find out the one that should take place in that work, but generally the reaction that takes place at the electrodes is what? Redox what? Reaction. Reduction is for what? Cathode. Oxidation is for what? Anode. Am I communicating? Yes, I'm communicating. Now, sorry. So now, what do you understand by surface area? What do you understand by surface area? Madam, what do you understand by surface area? Madam, what do you understand by surface area? That's the question. Okay, let me explain. If you have read rates of chemical reaction, then there's a topic in chemistry we call rate of chemical reaction. Now, factors that affect rate of chemical reaction. Surface area is there. If you get a lump of, let's say, a pellet or whatever of a particular reactant, and the powder form of that reactant, the powder form will react faster because the surface area it exposes the substance to be able to interact with the other reactant, two of us more. But if you use the lump, it need to break down first and expose the surface before the reaction can do what? Take place. So the rate of reaction is increases with with increase in what surface area. If surface area is more, reaction rate will be what more. Even in your house, that tea you make in your house, open a Milo or whatever Ovaltine or whatever, and if maybe air has entered, it's now in lump form. It's now as appear as lump. Put it and add milk and add water. We don't enjoy it. You want to wait for it to do what? Break down first and dissolve. True of us. In fact, as you are even taking it itself, you would want to be taking with more of water because the main thing has not what broken down. True of us, dissolve. Am I completely so? But if it is in powder form, if the surface is exposed, so it can easily react with particles of water, even though it's not chemical reaction as per se. But it is a solvation. It can interact, maybe use interaction. Interact with what? Surface of what? The water molecule to be able to do what? Dissolve. True of us. So surface area affect the rate of what? Chemical reaction. So if the surface area of the cathode is more, let's assume these two cathodes now. These are two cathodes, or you can use cathodes from different electrolytes, so different electrolytic cell. Now, if the surface area of this cathode is like this one is tiny. Tell me, rate of reduction or oxidation or what have you, which one will rate the faster? Which one? Anyone? Surface area, this one, right? No. The one that has larger surface what? Area. This one has larger surface area. True of us. So that's the point I'm going to make here. The next one, the next point is electrode potential. The next factor is electrode potential. Electrode potential. We are under electrode material. Electrode potential. Electrode potential. Electrode potential. Put down this. I want to be the person here. Yes.
People and transformers.
Sorry. Electrode potential. Are we together?
Yes, sir.
All right. A higher electrode potential. Put down. A higher electrode potential. A higher electrode potential can drive the reaction forward. A higher electrode potential can drive the reaction forward. A higher electrode potential can drive the reaction forward. A higher electrode potential can drive the reaction forward, thereby increasing the rate of discharge. A higher electrode potential can drive the reaction forward, thereby increasing the rate of discharge. A higher electrode potential can drive the reaction forward, thereby increasing the rate of discharge. With respect to what we're talking about now, the rate of potential here is just simply the potential difference. The potential difference here now, with respect to this topic now, this electrolytic cell, the electric potential is the potential difference between the electrode and the electrolytes. Electric potential is the potential difference between the electrode and the electrolytes. Am I communicating? So if the electrode is at higher potential to compare with the electrolyte, the discharge will be higher rate. Discharge will be higher rate. Huh? Now let's look at solution-related factors. Solution-related factors. No, the second group of factors. We are done with the first group of factors. Yes. Yes. We have 4 factors. So let's look at the solution-related factors. Yes. The solution/electrolyte-related factors. Which one? When I was I defined electrical potential. I said that is the potential difference between the electrode and the what? The electrolytes. Now the first factor under solution related factors. The first factor under solution related factor. Number 1. I said that the first factor under solution or electrolyte related factors. Number 1 is concentration of electrolytes. Concentration of electrolytes. Concentration of what? Electrolytes. Concentration of what? Electrolytes. Yes. A higher concentration can provide more ions. A higher concentration can provide more ions for discharge. In sciences, it's just a factor. There may be other factor playing in the background that may not allow it to happen. That's why I normally use that can. Is it clear? You can, yeah. So a higher concentration can provide more ions for what? Discharge. Thereby increasing the rate of reaction. Thereby increasing the rate of what? Reaction. Thereby increasing the rate of what? Reaction. A higher concentration is not the concentration of. I forgot to. Didn't we discuss it? In strong electrolyte and weak electrolyte, we say that if there is complete dissociation, there will be more ions. And we also say that the concentration of strong electrolyte is certain at the concentration of the ions. So if we have more of ions, if it's very concentrated, there will be more ions to discharge at the what? Cathode or the anode. Am I completing? Yes, I agree with that. The higher the concentration, the more ions available for what? Discharge. But the next factor is temperature. The next factor is temperature. Anyone? Example of what? That one is there are two specific example now. I have explained it that if higher concentration, we yield more ions. There are more ions. When the concentration of the electrolyte is high, there are more ions. Is it clear? Now, the temperature. Next factor is the what? Temperature. So what happens in temperature? I want us to limit our noise. See, the more we talk, the more I try to raise. See what your noise is making me to do. The more we make noise, the more I try to catch up. so that my voice will come up, so that others can hear me. The more I'm having headache, and the more I have headache, next time I'll be tired to come and teach. So why don't you quiet and listen? Now, temperature. Let's look at what? Temperature. So how does temperature affect? We want to look at how temperature affects the discharge. Now, remember your kinetic theory of matter. Yes, remember, you have done kinetic theory of matter, right? Have you done kinetic theory of matter? At least you know it now.
Yes.
You know the effect of temperature on the average kinetic energy. If the temperature increases, the average kinetic energy of the particles will do what? Increase. True of us? Good. Now, a ion is a component of matter. Remember, we discussed component of matter here: atoms, ions, and molecules. I only put about states of matter: solid, liquid, gas, and plasma. So I also talked about types of matter: mixture, elements, and compounds. Remember, so we also have subparticles of atom like protons, electrons, neutrons. Now, but a ion is a component of matter. So if a ion is a component of matter and temperature affects the kinetic theory of what? Of matter. That means temperature will have effect on the ions. Am I completing? So if there is high temperature, the average kinetic energy of the ions will do what? Increase. And if the average kinetic energy increase, what do you expect? Reaction will do what? Will be faster. True or false? Or put down. A higher temperature can increase the kinetic energy of the ion. So a higher temperature increases the kinetic energy. So that high temperature impacts on the kinetic energy of the ions. A high temperature. A higher temperature, put higher please. A higher temperature increases the kinetic energy of the ions. Energy of the ions. Increases kinetic energy of the ions. Increases the kinetic energy of the ions, thereby increasing the rate of reaction. Thereby increasing the rate of reaction. Thereby increasing the rate of what? Reaction. Thereby increasing the rate of what? Reaction. Full stop. Yes, I've explained that already, right?
Yes, sir.
Yes, I will. Because if the ions have more kinetic energy, as you can now, if you have more energy, the rate at which you wash plate in your house, cook food.
No.
True of us. But if the energy is down, you will not. You have to. All right, sit down. The next factor, pH. pH. The next factor is what? pH. pH.
That's more
Yes.
What's the formula of pH?
Political hydrogen.
I say it. Say it again. Huh? H plus. I can't hear you clearly. You say what? Power of what? Hydrogen. Is it actually power of hydrogen or concentration of? Is it actually power of hydrogen? Yeah, no, is it actually power of hydrogen? Is that the literal meaning?
Power, hydrogen.
Okay, you just give it power.
No, that's not I know it as. I was like,
Power. But it's actually negative logarithm of what? She said she said it's power of hydrogen. Tell us now. Tell us now. Wait, tell us. Who knows it? Tell us. Wait. Tell us. For you to say that what he said is not true. Tell us now. Are we together?
Yes, sir.
Basically, let's just listen carefully. pH is a measure of the acidity or alkalinity of a what substance. Basically, in terms of the meaning, unless you are asking for the literal what P stands for. Is that a question?
That is my own question. That is always a constant. T stands for what is a big graph.
Tell us what does P stand for? Power. See that P is power. No, we are talking about what P stands for, not the meaning. That P. P means. See the question here. Hello. Look at. Hello.
So why is the H bigger than
Wait now. Are we together?
Yes, sir. Yes.
Please, when you ask question, no answer the question. The question is, what does P here stand for? That's the question. And what is the meaning of pH? Is what does P stand for? And what does H stand for? And she said all that P stand for what? Power. And H stand for what? Hydrogen. Is it true? That's my question.
So why is the H bigger than
That's how they came to be.
Okay, it's you know what I mean.
If you write it, it can be misinterpreted for nothing. To make it special, to make what it is, the reason that is power. Are you okay now? Then in terms of definition, you can hello, are we together?
Yes, sir.
Hello. Can we grow?
Yes.
Grow now. Now, in terms of the meaning, you can define it quantitatively. You can define it qualitatively. Qualitatively, it can be defined as a measure of the alkalinity or acidity of a substance or a medium, period. You are not doing calculation now. Just that's why you use your liquid paper. Once you put it, it turns red. It is acid. You put it turns blue. It's alkaline. But you are not calculating the actual quantity measure. You are not giving the value. That's why I call this first one qualitative definition. But if you want to define it quantitatively, I'm saying things we are discussing. Continue. Listen, if you want to define it quantitatively, it's simply negative logarithm of hydrogen what? Concentration. So pH is simply quantitatively negative log. pH is minus log of hydrogen what? concentration.
Yeah, I know.
Quantitatively. Put what?
Okay, that is the calculation. What if now you change that hydrogen
To what? Hydrogen to the pH. Use all of this now and get it now. Use all of this and get it. Must I do that one for you? You want to make H the sort of formula. Is that what you mean? You got in the system, do that one now. Must I do that? You know I'm working on this and get the answer. Let's continue, please. The pH. Now, let's see how pH affects. Put down. Our time has elapsed, so put down. pH of this. Okay, sorry. A change in pH can alter the concentration of ions. A change in pH can alter the concentration of the ions.
So the ions are just change.
Yeah. If it can alter the concentration. I'm coming. I say that a change in pH can alter the concentration of the ions, influencing thereby influencing the rate of what? Discharge. A change in pH can alter the concentration of ions, thereby influencing the rate of what? Reaction. Thereby doing what? Influencing the rate of what? Reaction. Thereby influencing the rate of what? Influence now. Rate of reaction. Yes. People have caused me headache. Let me write this and go. Keep quiet now. My head is pounding. Yes, I'm too that level of pH.
What is another one?
Yes, impurities. Next one is what? Next factors is impurities. Presence of impurities. Presence of impurities. It's something now. It's something. Anyone you like, you write. It's something. You can do anything now. As you are here now, if you are not wanted in this class, you become an impurity in our midst. You know? Am I completing? If you want to cook rice, if you want to cook rice, and sand is in that rice, and you don't need that sand becomes what? Impurity. So if there is any other thing inside this setup, not different, you don't need. Hello? If there is any other thing inside these electrolytes, you don't need. In this reaction, it becomes what? An impurity. But sometimes you may say have the ones you need, that is not the main thing, they become what? Additives. Put down. See, let me tell you what you don't know. The more you make noise, the more I take note and go. You are losing. Keep making noise, you are losing. After you say making noise again, I want to answer that question. I want to answer. Keep making noise. Yes. Just put on note. Maybe talk a minute. I want to answer that question. I want to answer. Don't tell me. I don't want to know. I'm not interested. Let's continue. Impurities can alter the concentration of ions. Impurities can alter the concentration. You're not serious. After you take note for this period, impurities can alter the concentration. Maybe I'll tell him. People here are more serious.
Concentration of.
I said that. Let me sit down here. Sorry, my dear. Impurities can alter the concentration of ions or react with the electrolytes. Impurities can alter the concentration of ions or react with the electrolytes, thereby affecting the rate of discharge. Affecting the rate of what? Discharge. Thereby affecting the rate of what? Discharge. Now let me explain. Sometimes there may be impurity. There may some when I said impurities, I mean there are some things that is not needed inside the electrolytes, and they will be there. They become impurity. Am I competing? And sometimes that impurities may start reacting with the electrolytes. And remember, it's the ions in the electrolyte that undergo the reaction, true or false? So if the impurities start reacting with the electrolytes, they will be busy reacting. Instead of going to discharge, they are there reacting with the what? Impurities. So if they are there, just like you want to pass through this place, right? And I'm here, I'll hold you. If at all you get to this board, at all, if you finally get to this board, you get the blades, two of us. Hello. This way they have caused me headache. Serious headache. Since I'm here now, calm, quietly. I'm calm. Alright, let's continue. Hello. Are we together? I said that the next factor is what? What I explained about impurities is clear, right? When there's impurity, they will be busy with the what? Ions, right? Reacting that ion may not be able to get to the what? Electrode. True or false? Now, let's look at the electrolyte composition. I take down the type here. Column. The type and concentration of ions. The type and concentration of ions. See, do you know? It's better for me that two people are writing than the headache you're giving me there. This is the fourth time I'm apologizing. Alright, so let's continue. Hello, those that read Bible here, those that are Christian here. You don't say that what? That Christ came for the sinners. So I'm here for those that don't know. So this way they don't know. So you don't know. If you know, you don't make noise. So I came for people that don't know. So people here don't know, right? So let me teach people that don't know. They should keep making noise there. Alright, so now I am making noise. Hey, now wow. God bless you. So the type and concentration of ions, as well as the presence of additives the type and concentration of ions. What are you saying? All right. Okay. It's okay. Let me say that first. I said that the type and concentration of this one. I say that the type and concentration of ions, as well as the presence of additives or complexing agents can influence the rate of discharge. Now let me explain. I think that let me explain this. Listen carefully. You know, there may be other things that can be added here. They may not necessarily be what? Impurities. Okay? They may not necessarily be what? Impurities that can influence the rate of what? Reaction. Am I communicating? They may not be impurities, but it becomes disadvantageous if they are what? Impurities. If they become additives if they are not what? Impurities. Okay? If they are added intentionally, depending on what you want to do, achieve. Now, so they also influence the rate of discharge. That's the point I'm making. So with this now, we are through with the factors that influence the discharge of ions. In our next class, by God's grace, that should be on Tuesday, we go over to laws of electrolysis. We go to Faraday's first law, second law. Please prepare yourself for calculation. We will do calculations on Faraday's laws. Have you done it? Okay, okay, you're ready now. Okay. Hello. Are we together? How many people have done it here? Raise your hand. Don't worry, I do my thing. I'll teach it. Yeah, I'll teach it. All right. Any question? That's what this year. I'll answer a question today. Lie. I will not answer a question for today. Lie. Until repents. No problem. Don't ask. You're making noise in my class. All right. Thank you very much for your attention. God bless you. We'll see you in our next class.